The Government of India and Government of Bhutan joined hands for mutual benefit of people of both the countries and decided to construct a mega hydropower project, 1,200 megawatt Punat Sangchu 1 project, located 7 kilometers downstream of iconic Wangdu Bridge in Wangdu Phodrang district of Bhutan. The project was progressing well at breakneck speed 24/7 and without a break even on weekends. On a fateful morning on 23rd July 2013, when over 2 lakh cubic meter excavation was progressing every month, disaster struck the project and Right Bank Mountain moved from its location, causing catastrophic damages. After the dust of the disaster began to settle down, the engineers carried out subsoil investigation at a scale. Once the plane of the failure was established, the engineers decided was to develop foundations of the dam blocks in the right bank on large diameter board cast in situ RCC piles. To make some of the lost time, and 3 large-sized rotary rigs BG-40 were mobilized from Germany. The engineers figured out that manual construction of reinforcement bar cage for 2-meter dia, 68.5-meter deep RCC piles could not match the speed of planned piling works. The task was identified as most challenging. Several brainstorming sessions were undertaken to find the solution. The mechanical and geotechnical team came out with a proposal to shop fabricate the cage in mechanical fabrication workshop. A clear objective was set. The bored holes drilled for the piling should never starve for want of fabricated reinforcement cage. It was decided to fabricate the cages in jigs and fixtures in order to match the required speed for fabrication and supply with dimensional accuracy of rebar cage for effective splicing of cages while its installation. The raw brains from project execution team quickly developed a pair of jig frames to hold in position the 31 numbers of 32 mm diameter rebars, each of 12-meter length, which should be mobile as well to move along with the progress of fixing the stirrup rings. The mechanical team had faced many challenges while setting out the fabrication of cage at workshop. Several process improvement techniques were undertaken by the team. Sagging of main bars outside the moving jig, which was successfully overcome by placing horizontal spacer supports by providing removable bottom supports with screw jack and beam. One of the quality and productivity issue faced was stiffener ring and stirrups. The problem was addressed by making a ring-making machine out of used spare motor and a gearbox located from scrap machineries, which not only improved the quality of shape of ring but also increased the productivity from 0.2 metric ton per man day to 1.25 metric ton per man day. Similarly, in the beginning, bending of lifting legs were carried out manually. It required significant number of workmen and involved high amount of physical work. To overcome this, the team made use of hydraulic cylinder by converting it into a hook bending press. This made drastic change in output from 0.1 metric ton per man day to 3 metric ton per man day. By adopting these processes of innovations, the production time for 3.1 metric ton cage improved from 1.5 shift per cage to 0.7 shift per cage, consisting 1 skilled and 2 semi-skilled workmen. 11,776 running meter of 2-meter pile was completed with a clean safety record. With very good quality performance, the customer are happy and satisfied. Piling activity is very common across infrastructure projects, and this method could be used in a very cost and time-effective manner where a moderate-sized fabrication setup is available. L&T team has added one more feather to its cap with regard to innovation-led performance excellence in Bhutan hydropower project.